Alright, so for number 1, I went ahead and I listed the p factors. Remember, these are factors of the constant of 4. And the q factors, these are factors of the leading coefficient, which is 3 in this case. And then, that's not it. You have to find the ratio p over q. And so you take each one of these and put it over each one of these. So 1 over 1 is 1, 1 over 3 is 1/3. 2 over 1 is 2, and 2 over 3 is 2/3, and then I did the same thing with 4. Okay, and so now I set up the synthetic division, but in the second way I showed you, where because I don't know how many times I'm going to have to do synthetic division before I find the 0, so I'm going to just go ahead and set it up this way. So I start out with 1, bring down the 3. 3 times 1 is 3. 3 minus 10 is -7. -7 times 1 is -7. -7 plus 10 is 3. 3 times 1 is 3. 3 minus 4 is -1. So this one did not work. I go on to the next number. I'll just try 1/3. I'm going to go in order. 3 times 1/3 is 1. I'm sorry, bring down the 3. 3 times 1/3 is 1. 1 minus 10 is -9. -9 times 1/3 is -3, because it's -9 over 3, so -3 plus 10 is 7. And this is where I'll stop, because 7/3 does not simplify to a whole number or an integer, and it's just going to give me more fractions, and I need whole numbers. I need integers, not fractions. So I'm going to stop right here, because this is going to give me fractions. Move on to the next number, 2. And so bring down the 3. 3 times 2 is 6. 6 minus 10 is -4. 2 times -4 is -8. -8 plus 10 is 2. 2 times 2 is 4. 4 minus 4 is 0. So there it is. Okay? And the quadratic that I have left is 3x squared minus 4x plus 2. I checked to see if it factors, so factors of 6x squared that add up to -4 doesn't factor, it doesn't work that way. So then from here what I'm going to do is use a quadratic formula. So x equals the opposite of b plus or minus the square root of b squared. Remember, you have to square the negative also. Minus 4 times a times c all over 2a. So this gives you 4 plus or minus, now this is 16, I'll just write it out, 16 minus 24 all over 6. This gives you 4, so 16, that's 8, square -8. So 8 is 4 times 2, so it's 4 times 2. The 4 is going to come out as a 2 when I take it out, and the negative is going to come out as an I. So you're going to end up with 4 plus or minus 2i. This 2 right here stays inside the radical, okay, over 6. So you look at the outside numbers, the 4, the 2, and the 6, and look to see if they have a common factor. And these do, so 2 is a common factor. Over 2 times 3. So the 2 over 2 reduces to 1. And so now I have the zeros, which are 2. I got that from, remember, from the synthetic division over here. Don't forget about that one. And then 2 plus or minus I radical 2 all over 3. So here are the 3 zeros. 1 real, 2 imaginary. Now when you see a 4-termed polynomial, and usually it's a third degree, I check to see if it factors by grouping, and if it does, then it saved me a lot of work as far as, in the factoring, So I'm going to see if that works here. So x squared, x minus 3, and 4, and 4 times -3, 4 times -3 does give me -12, so yes, it's correct. So this polynomial is x minus 3 times x squared plus 4. So now I have to find the zeros, okay? So the zeros, for the first factor, the 0 is 3. for the second factor, for this one, I'm going to set it equal to 0. And that gives me x squared equals negative 4. Oops, too many negatives, sorry. Take the square root. So x equals plus or minus. Now the square root of 4 is 2. The square root of negative 1 is I. So my two zeros are plus and minus 2i. So here we have one real 0 and two imaginaries. So now we're solving the equation, the polynomial, finding all the roots. Okay, so I'm going to try and see if it factors again like this. And if it doesn't, this is a very fast check, so if it doesn't work, it's not wasted time really. At least you know that it didn't factor this way. So I can factor out an x squared, 2x, minus 3, and 4. So 4 times negative 3 is negative 12. Again, it worked. So the factors are 2x minus 3 and x squared plus 4. Okay? And one side is 0. So the 0 for the first factor is 3 over 2. And then example number 2 had the same exact factor, x squared plus 4. So then I know it's plus or minus 2i without needing to have to do the work again. Okay, there it is. Alright, for number 4, it's a fourth root, it's a quartic, a fourth root. And I noticed that they all have a common factor of x. So I'm going to go ahead first of all and factor out the x. Okay, so since 1 is, let me put it right here. P is just plus or minus 1, and so is Q, right? Plus or minus 1. And, oh, by the way, I could try putting x cubed minus 5x squared plus 3, like this polynomial, into a little box and see if it factors. But I can tell by looking at it that it won't. But if you want to go ahead and, do this, and you'll see that it doesn't work. Okay, that's why I'm going to the P's and Q's. Well, the nice thing about this problem is that P over Q gives you only plus or minus 1. That's it. So I'm going to do 1, and I'll set it up the original way, just because there's only two numbers to try. So if 1 doesn't work, then I'll try negative 1. So bring down the 1, negative 4, negative 4, negative 1. Oops, it's a negative 1. Negative 1, 0. It worked. So this means my quadratic is this one. It doesn't factor, so I have to use quadratic formula. So I'll do that over here. X equals the opposite of b, negative b, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a, which is 1. So this gives you 4, and we've got 16 plus 4, which is 4 plus or minus radical 20. So square root of 20 is 4 times 5. So the 4 comes out as a 2, and you're left with 4 plus or minus 2 radical. Now the 5 stays inside because it doesn't have a partner factor. And then you look at all the outside numbers, this one, and this one, all three of them, and see if there's a common factor with all three. And it is 2. And so it cancels out. So finally, the zeros, okay, so go back to the original. Don't forget we factored out an x, okay? So that's going to give you a 0. Then with synthetic division, we found 1. And then right now with quadratic formula, 2 plus or minus radical 5. So this one gives me two rational solutions, the 0 and the 1, and two irrational solutions with the 2 plus and minus radical 5. Alright, so for 5 through 8, we have to find polynomials with the given zeros. The numbers in black are the ones that are in your book. The one in pink is the one I had to add in to make sure that this has its conjugate pair. okay, because they have to be together, this one and this one. So let's go through, and the factor for 0 would be x. The factor for radical 5 would be x minus radical 5. The factor for 2 would be x minus 2. And the factor for for negative radical 5 would be x plus radical 5. So what I would do is I would multiply these together and these together. The reason for that is that I want the radicals together because it'll make your job easier. So let me go ahead and I'll do this pair first, the green pair. So that's going to give me x squared minus 2x. Then I'll do the pink pair, these two right here. That's going to give me x squared plus radical 5x minus radical 5x minus square root of 25. Okay, now we're simplifying. Well, this one there's nothing to simplify. Just bring it down. This one is x squared, radical 5x minus 5x is 0, and then square root of 25 is 5, so this is minus 5. So now I have another pair of binomials, so that's going to give me x to the 4th minus 5x squared minus 2x cubed plus 10x. Okay, so just put it in standard form. So x to the 4th minus 2x cubed minus 5x squared plus 10x. So this is the polynomial that would give you these zeros up here. Alright, so for number 6, I had to add the negative 4i. Okay, the numbers in black were the ones that you got in the book. And the pink one is the one that I had to add in, or you guys have to add in, because again, these have to be together as conjugate pairs. So the 0 for 4i would be x minus 4i, I mean the factor. The factor for 2 would be x minus 2. The factor for minus 2 would be x plus 2. And the factor for negative 4i would be x plus 4i. Okay? So just like I did on the previous problem, I'm going to pair them up so that to make my job easier, I'm going to multiply the ones with I together and then the ones that are just real numbers together, like that. So I'll use the green ones first. So that's going to be x squared plus 4ix minus 4ix minus 16i squared. And then the pink ones, x squared plus 2x minus 2x minus 4. Okay, now we're going to simplify. The 4ix minus 4ix, that's gone. So let me just write it like this. The negative, remember, I squared is negative 1, and there's already a negative 1 right there. So negative 1 times negative 1 is positive. Over here with the pink polynomial, this cancels, and you're left with x squared minus 4. So now we're going to multiply this together. X to the 4th minus 4x squared plus 16x squared minus 64. Combine like terms, I can combine those two, and you get x to the 4th plus 12x squared minus 64.